Comparative Cardiac Anatomy and Physiology, Racing Pigeons versus Humans. Abstract. The cardiovascular system, and the heart in particular, plays a vital role in the survival and performance of all vertebrate species. While the fundamental structure and function of the heart are broadly similar across different animals, there exist notable variations tailored to the specific physiological demands of each organism. This report delves into the distinctive features of the racing pigeon's heart, drawing comparisons with the human heart to elucidate the evolutionary adaptations that enable these remarkable avian athletes to excel in their demanding sport. Through a comprehensive examination of anatomical, cellular, and biochemical differences, this report aims to shed light on the intricate mechanisms that underpin the exceptional cardiovascular capabilities of racing pigeons. Introduction. Racing pigeons, a breed selectively cultivated for their exceptional endurance and speed, represent a fascinating example of evolutionary adaptations within the avian cardiac system. These birds are capable of sustained flight over vast distances, often covering hundreds of kilometers in a single journey. Such extraordinary feats necessitate a highly optimized cardiovascular apparatus, enabling efficient oxygen delivery and waste removal to meet the intense metabolic demands of prolonged exertion. In contrast, the human heart, while remarkable in its own right, is primarily adapted for the sedentary lifestyle that has characterized much of human existence. Although capable of remarkable feats during short bursts of activity, the human cardiovascular system is not designed for the sustained, high-intensity workloads routinely experienced by racing pigeons. This report aims to explore the key differences between the hearts of racing pigeons and humans, highlighting the unique adaptations that enable these avian athletes to excel in their demanding sport. By examining various aspects, including anatomy, cellular composition, biochemical pathways, and regulatory mechanisms, this analysis will shed light on the intricate interplay between form and function in the cardiovascular systems of these two species. Anatomical differences. Gross anatomy. One of the most striking differences between the racing pigeon's heart and the human heart lies in their relative sizes. Racing pigeons possess a significantly larger heart in proportion to their body mass, an adaptation known as cardiac hypertrophy. This enlargement of the heart muscle allows for increased blood pumping capacity, which is essential for meeting the heightened oxygen demands during prolonged flight. In humans, the heart typically accounts for approximately 0.5% of the total body weight. In contrast, the heart of a racing pigeon can constitute up to 1.5% of its body mass, representing a threefold increase in relative size compared to humans. Hartman, 1955. This remarkable cardiac hypertrophy is a key factor contributing to the exceptional endurance of these avian athletes. Cardiac chambers. While both the racing pigeon and human hearts consist of 4 chambers, 2 atria and 2 ventricles, there are notable differences in their relative proportions and configurations. In racing pigeons, the left ventricle, which is responsible for pumping oxygenated blood to the body, is significantly larger and more muscular than the right ventricle. This asymmetry is even more pronounced compared to the human heart, where the left and right ventricles are more evenly sized. The increased size and muscularity of the left ventricle in racing pigeons enable it to generate higher pressures and greater stroke volumes, facilitating the efficient distribution of oxygenated blood to the working muscles during flight. This adaptation is crucial for sustaining the elevated metabolic demands associated with prolonged exercise. Butler, 1991. Cardiac valves. The valves within the heart play a critical role in regulating blood flow and preventing backflow. While the basic structure and function of these valves are similar in racing pigeons and humans, there are subtle differences in their morphology and biomechanics. In racing pigeons, the atrioventricular valves, mitral and tricuspid, and semilunar valves, aortic and pulmonary, tend to be thicker and more robust compared to their human counterparts. This increased thickness is thought to be an adaptation to withstand the higher pressures and flow rates experienced during intense physical exertion. Feta et al., 1998. Additionally, the chordae tendineae, which are fibrous strings that connect the valve leaflets to the papillary muscles, are generally shorter and thicker in racing pigeons. This configuration allows for more efficient valve closure and reduces the risk of regurgitation during rapid heart rates and high cardiac output states. Baumel et al., 1993. Cellular and molecular differences. Cardiac muscle cells, cardiomyocytes. At the cellular level, the cardiomyocytes, cardiac muscle cells, of racing pigeons exhibit several unique characteristics that contribute to their exceptional performance. Mitochondrial density. Racing pigeons possess a higher density of mitochondria within their cardiomyocytes compared to humans. Mitochondria are the cellular powerhouses responsible for producing adenosine triphosphate, ATP, the primary energy currency of the cell. The increased mitochondrial density in racing pigeon cardiomyocytes enables more efficient energy production, which is critical for sustaining the high metabolic demands of prolonged flight. Feta et al., 1998. Myoglobin content. Myoglobin is a protein found in muscle cells that facilitates oxygen storage and diffusion. Racing pigeons have higher levels of myoglobin in their cardiomyocytes compared to humans. This increased myoglobin content enhances the oxygen carrying capacity of the cells, ensuring an adequate supply of oxygen even during periods of high oxygen demand. Butler and Wokes, 1982. Calcium handling. The contraction and relaxation of cardiomyocytes are regulated by the precise handling of calcium ions, Ca2+. Racing pigeons possess specialized mechanisms for efficient calcium cycling, which allows for faster and more powerful contractions. This adaptation is facilitated by higher expression levels of calcium handling proteins, such as ryanodine receptors and calcium ATPase, in the cardiomyocytes of racing pigeons. Vornanen, 1998. Metabolic pathways. The metabolic pathways involved in energy production and utilization exhibit notable differences between racing pigeons and humans, reflecting their distinct physiological demands. Fatty acid oxidation. Racing pigeons rely heavily on fatty acid oxidation as their primary energy source during prolonged flight. This metabolic pathway is more efficient in terms of ATP production per unit of oxygen consumed compared to carbohydrate metabolism. The enhanced capacity for fatty acid oxidation in racing pigeon cardiomyocytes is facilitated by increased expression of enzymes involved in this pathway, such as carnitine palmitoyltransferase and acyl-CoA dehydrogenases. Lundgren and Kiesling, 1985. Glycolytic capacity. While fatty acid oxidation is the predominant energy source during sustained flight, racing pigeons also possess a heightened capacity for glycolysis, the breakdown of glucose, to meet short-term, high-intensity energy demands. This is achieved through increased expression of glycolytic enzymes, such as hexokinase and phosphofructokinase, in the cardiomyocytes of racing pigeons. Lundgren and Kiesling, 1988. Regulatory mechanisms. Cardiovascular regulation plays a crucial role in ensuring that the heart can adapt to varying physiological demands, and there are notable differences in the regulatory mechanisms between racing pigeons and humans. Autonomic nervous system. The autonomic nervous system, comprising the sympathetic and parasympathetic branches, is responsible for modulating heart rate, contractility, and vascular tone. In racing pigeons, the sympathetic nervous system appears to be more highly developed and sensitive compared to humans. During flight, racing pigeons experience a profound increase in sympathetic activity, leading to a significant elevation in heart rate and contractility. This enhanced sympathetic response enables the heart to rapidly adapt to the increased metabolic demands of exercise. Ollie and Tomlinson, 1971. Conversely, the parasympathetic nervous system, which is responsible for slowing heart rate and promoting vasodilation, appears to be less active in racing pigeons during flight compared to humans at rest. Endocrine regulation. In addition to neural regulation, the cardiovascular system is also modulated by various hormones and signaling molecules. One notable difference between racing pigeons and humans lies in the role of natriuretic peptides. Natriuretic peptides, such as atrial natriuretic peptide, ANP, and brain natriuretic peptide, BNP, are hormones secreted by the heart that promote vasodilation and sodium excretion. In racing pigeons, these peptides appear to play a more prominent role in regulating cardiovascular function during exercise. Studies have shown that racing pigeons experience a significant increase in circulating levels of ANP and BNP during flight, which contributes to the regulation of blood pressure and fluid balance. Kovacs et al., 1997. This adaptation may help prevent excessive fluid retention and maintain optimal cardiovascular performance during prolonged exertion. Vascular adaptations. The cardiovascular system encompasses not only the heart but also the vast network of blood vessels that distribute oxygenated blood throughout the body. Racing pigeons exhibit several adaptations within their vascular system that complement the unique features of their hearts. Capillary density. To facilitate efficient oxygen and nutrient delivery to working muscles during flight, racing pigeons possess a higher density of capillaries within their skeletal muscles compared to humans. This increased capillary density enhances the surface area for gas exchange and reduces the diffusion distances for oxygen and metabolic waste products. Mathieu Costello et al., 1992. Vascular reactivity. The ability of blood vessels to dilate or constrict in response to various stimuli is crucial for regulating blood flow and tissue perfusion. Racing pigeons exhibit heightened vascular reactivity, particularly in response to vasodilatory signals, such as nitric oxide and endothelium-derived relaxing factors. This adaptation allows for more efficient redistribution of blood flow to active muscles during exercise. Wagner et al., 1997. Conclusion. The comparative analysis of the racing pigeon's heart and the human heart reveals a remarkable array of evolutionary adaptations that enable these avian athletes to excel in their demanding sport. From the gross anatomical level to the cellular and molecular intricacies, the racing pigeon's cardiovascular system is finely tuned to meet the intense metabolic demands of prolonged flight. The larger relative heart size, increased left ventricular dominance, and robust valvular structures of racing pigeons provide the foundation for their exceptional cardiovascular performance. At the cellular level, the higher mitochondrial density, myoglobin content, and efficient calcium handling mechanisms contribute to the enhanced energy production and contractility of cardiomyocytes. Furthermore, the metabolic pathways in racing pigeons are geared towards optimizing energy utilization, with a preference for fatty acid oxidation and a heightened capacity for glycolysis to meet short-term energy demands. Regulatory mechanisms, including an enhanced sympathetic nervous system response and specialized endocrine signaling pathways, enable rapid cardiovascular adjustments during exercise. While the human heart is a marvel in its own right, the unique adaptations of the racing pigeon's heart serve as a testament to the remarkable evolutionary processes that shape the cardiovascular systems of different species to meet their specific physiological demands. By understanding these intricate differences, we not only gain insight into the remarkable feats of endurance exhibited by racing pigeons but also uncover potential avenues for translational research. The knowledge gained from studying the racing pigeon's cardiovascular system could potentially inform the development of novel therapeutic strategies or biomimetic engineering solutions aimed at enhancing human cardiovascular health and performance. Ultimately, this comparative analysis underscores the profound impact of evolutionary pressures on shaping the intricate form and function of biological systems, reminding us of the incredible diversity and complexity of life on our planet. I'm an experienced ex-pigeon racer from England, and I can offer valuable insights and guidance on all aspects of pigeon racing, from breeding to racing. During my racing days, I managed a small team of no more than 70 pigeons, including stock, young birds, and old birds. It was not uncommon for me to send as few as 6 birds to a race and still secure the top 3 positions out of up to 2,500 pigeons in my club and federation. My race distances typically ranged up to 300 miles, and I consistently achieved top 5 placements in my club. My expertise extends to the art of selecting excellent breeders, including evaluating pigeons based on their eye-sign characteristics. I firmly believe that true champions can only be bred from top-quality stock, and I can guide you in identifying and acquiring such pigeons. I understand that many pigeons for sale are advertised based on their lineage or pedigree, but I emphasize the importance of assessing the bird itself rather than relying solely on paperwork. As part of my offer, I invite you to share photos of your pigeons, including their eye-sign and wing characteristics. I'll provide you with free advice on racing and breeding based on my extensive experience and knowledge. Additionally, I will share auction links to high-quality breeding birds that have the potential to produce winners in your loft. Here's what you can expect to receive from me: a comprehensive Word document containing valuable insights and strategies for successful pigeon racing, including specific racing methods for both old and young birds, as well as general advice. Private YouTube videos sent to your email, covering various aspects of pigeon racing, from breeding to race preparation. Detailed recommendations on supplements and additives to add to your pigeon's drinking water, with scientific evidence supporting their effectiveness. Similar products are used by professional athletes and racehorses to enhance performance. Assurance that your pigeons will race home faster, provided that you have quality birds to begin with. While I can provide guidance, it's essential to start with pigeons of good genetic quality. Guidance on feeding schedules and methods, tailored from Sunday to Saturday, to optimize your pigeon's performance. The understanding that there are no big secrets or magical products that guarantee success in pigeon racing. Instead, success hinges on developing a racing system that suits your loft and pigeons. I'm committed to providing full support even after you receive this information, as I want to see you succeed in pigeon racing. Feel free to reach out if you have any questions or need further assistance. Remember, the key to winning in pigeon racing lies in knowledge, dedication, and continuous improvement.